Welcome back to TRIS Junior Scientist. I am Pravastika from the Radiant International School from grade 8. Today, we are going to explore a fascinating instrument used to measure the electric current, the tangent galvanometer. This device is a great example of applying the principle of electromagnetism. Let's dive right in. Normally, we use a moving coil galvanometer in which the coil moves. But in tangent galvanometer, the coil remains stationary and the needle deflects. Here we have a tangent galvanometer composed with a circular coil of wire, a compass needle in its center. The key concept of here is that the deflection of the compass needle is proportional to the tangent of the angle of deflection. Let's take a closer look to its components. The compass needle, which is free to rotate, aligns itself with the resultant magnetic field created by the coil and the Earth's magnetic field. Here is a simple diagram. When the current flows through the coil, it generates a magnetic field perpendicular to the plane of the coil. The Earth's magnetic field is horizontal. The needle deflects to align with the vector sum of these two fields. Let's set up a practical demonstration. Here we have a battery emitter, an ammeter, a variable resistor and our tangent galvanometer. I will connect the tangent galvanometer in series so that the current passes through the circuit also passes to the galvanometer. Ensure that all connections are secure for getting accurate reading. Before we start, we need to rotate the coil so that the plane of the coil is parallel to the magnetic needle when no current is flowing. This ensures that the Earth's magnetic field is probably accounted for. Now, I will vary the resistance using the variable resistor. As I do this, the current in the circuit will change and we will observe the needle moving on the galvanometer. Watch closely as I adjust the resistor. You can see the needle moving on the galvanometer. The deflection angle theta can be measured using the scale on the galvanometer. According to the tangent law, the current I is proportional to the tangent of the angle theta. And that's how we use the tangent galvanometer to measure the electric current. It is a powerful tool for understanding the relationship between the electric current and the magnetic field. Thank you everyone for watching. If you found this video helpful, please give it a thumbs up and subscribe to our channel.